Hello, in the second part, we are going to see number 2, how to duplicate a voxel image or a voxel cube image using a CT scan. For this reason, we have an example here of an image. What I wanted to show you in this example is that the image is showing different media. Over here we have different media. We have the bone. Take another color. Okay, there's the bone, the brain tissue, some other tissues. Anyway, each tissue has a different degree of absorption because each medium has its own absorption coefficient. Now, if we divided this part, this small part here, into 4 squares, okay, and we associate each square by a number that represents how strong or weak the absorption is. Let's say that we associate this square by 3, and this by 4, this by 8, and the other by 5. The smaller the number means the more is absorption. Let's remove this image for now. We don't need it anymore. Erasing these and starting over again. So the 4 pixels that I have with the 4 numbers that are 3, 4, 8, and 5. Okay, now at the beginning we radiate from this side. The detectors will count them as 3 plus 4, that's 7, 8 plus 5, that's 13, and will develop them by the computer as new 4 pixels that are 7, 7, 13, 13, radiating now diagonally like this, because you know we are rotating the gantry with the patient at the middle, and we are hitting him by X-ray from different directions. Here we get diagonally 4, 3 and 5, 8 and 8. Now taking these 3 numbers and adding them diagonally to what we got there, the result will be okay, 4 and 7, that's 11, 8 and 7, that's 15, 8 and 13, that's 21, 8 and 13, that's 21. Stage number 3, we radiate from above, and this will result in a new number taken by the detectors that are 9 and 11. Now again, placing the 9 and 11 there and adding them, we get 20, 9 and 21, 30, 11 and 15, that's 26, 11 and 21, that's 32. And finally, radiating it diagonally but from the other side, the detectors in this case will read 5, 4 and 8, that's 12 and 13, taking them and adding them there as 3, 12, and 5 to come up finally with 3 and 26, that's 29, 12 and 20, that's 32, 12 and 32, that's 44, and 30 and 5, that's 35. And this is the last result over here as read by the computer. Notice that we can always redevelop the background readings or the first readings over here. Notice that the number of the initial intensity number is 3 and 4 and 5 and 8, that gives 20 again. So adding the 3, 4, 5 and 8, the result is 20. Notice that if I subtract 20 from the result here, subtracting 20, we get 12, 9, 24 and 15. And then if we divide by 3, we get again the initial background reading. That is 12 divided by 3, 4, 9 divided by 3, 3, 24 divided by 3, 8, and 15 divided by 3, 5. So we again get the same readings as initially taken by the detectors. Dividing by 30 is always, and it's constant, but subtracting number here depends on the sum of the background initial intensities. Okay, and by the way, you have another example in your paper. You can also see the example that is in your paper.